Hi all, let's work through a couple more, little bit on the messy side radical equations just for good measure. If you feel like you're kind of getting the hang of this, you're welcome to pause, try the problem on your own, and then check yourself. Otherwise, I'll work through these. We do have w's on both sides for this first equation, which means it won't just be an inverse operations solve. I do need to work on getting my w's on the same side, but right now one of my w's is stuck under the square root, so I need to deal with that first. So first thing, clear out any mess. Clear out square roots that your variable stuck in, parentheses that your variable stuck in, fractions that your variable stuck in, anything like that. Here, I am ready to go ahead and immediately eliminate the square root because it's already isolated. I already have everything outside of the square root separated out from the right-hand side. So if I square, I will get a w minus 1 squared, which is w minus 1 times w minus 1. And then the square root of 6 minus 6w squared will just be 6 minus 6w. The square root and the square do, in fact, cancel. So I have a w squared minus a 2w plus 1 equals 6 minus 6w. I have now successfully turned my radical equation into a quadratic equation. If there was only a single w floating around, I would solve with square roots, but there's not, so I'm going to set it equal to 0, and then I can decide between factoring and the quadratic formula. To set it equal to 0, I'll subtract 6 from both sides and add 6w to both sides. This will leave me with a w squared plus 4w minus 5 equals 0. So let's go ahead and give factoring a try. If you get stuck, you can always go for a quadratic formula if you think it's not factorable, but factoring is much easier than the quadratic formula. I know sometimes people like quadratic formula just because it always works, but it is so easy to make a mistake in those calculations, whereas if you keep practicing your factoring, you'll get good at it, and you should be pretty quick, and you probably won't make that many mistakes factoring. So here I'm going to split up a w and a w. I need factors of negative 5 that add up to 4, so that's a positive 5 and a negative 1. Remember, this is way easier when there's a 1 in front of the w squared. You only have to look at factors of negative 5 that add up to 4. This means that w plus 5 has to equal 0, or w minus 1 has to equal 0. So w will equal negative 5, or w will equal 1. We need to check both of these solutions. When w equals negative 5, remember we're going all the way back up to the original equation. I get negative 5 minus 1, which is negative 6, equals the square root of 6 plus 30. That becomes plus 30, so 36. And this is a no-go. I should be worried as soon as I see this negative 6 over here equal to a square root, because that's a positive root, and you will always get a positive number out of a positive root, or at least a non-negative number. You can get 0. So this is not true. We will throw away the w equals negative 5. When we check w equals 1, we get 1 minus 1, which is 0, equals the square root of 6 minus 6, which is also 0, and that is absolutely true. The square root of 0 is 0, so we get one and only one solution. Again, there's not a rule that if you get two solutions, one will work. They could both work, they could both not work, so always just check carefully. So my final answer is just w equals 1. That's all that I will give. One more. Let's see, 2 times the square root of k minus 3 plus 4 equals k plus 1. That's kind of got a lot of mess going on. I have k's on both sides of the equation, so I can't just use inverse operations. I can work a little bit to isolate the square root. So if I need to work on getting k's on the same side, I first want to free the k up from the square root. I can't combine those and mush them together when there's a k stuck under the square root. So my first step is going to be to subtract 4. So I am going to actually start with a little bit of inverse operation stuff. To isolate the root, I need to first subtract the 4. So I get 2 square root of k minus 3 equals k minus 3. I then need to divide by 2. and I get square root of k minus 3 equals k minus 3 over 2. That's kind of an interesting one. Now I'm finally ready to square both sides. And I will say that this last step, if you'd like to, you could have squared there as long as you don't forget to square the 2. We had to do that earlier, so that is an option if you want to avoid the fractions. I just find that if I force myself to always isolate, I won't ever make a mistake with that too. So I now have k minus 3 equals k minus 3 squared over 4. So if you're squaring a fraction, remember that's multiplying it by itself. And I guess I could have gone ahead and multiplied out that k minus 3 squared, but the big thing I wanted to do was separate off the 4 to say that I'm going to go ahead and move that right back to the other side because I don't want the fraction in the mix. So I'll get 4k minus 12, and then k minus 3 times k minus 3 will be a k squared. So again, what am I doing here? This is k minus 3 times k minus 3. That's what k minus 3 squared means. Minus 3k plus 9. Okay, I've successfully turned it into a quadratic, and in fact, I've successfully turned it into a quadratic that doesn't have fractions, because that sounds kind of terrible. To solve a quadratic, you either want to use square roots if there's only one k. There's tons of k's here, so instead I'm going to set it equal to 0 and try to factor. If I can't factor, I'll either complete the square or use a quadratic formula, but I will try. So I have 0 on the left. I have a k squared. There's a bunch of these. I have negative 3k minus 3k, so that's negative 6k. Minus 4k, that will be negative 10k. And then 9 plus 12 is 21. This is another nice one. It's a 1 in front of the k, so this should be pretty easy to sort out whether it factors or not. I'm looking for factors of 21 that add up to negative 10. And that sounds to me like, what's 21? 3 times 7 would give me 10. If I want it to be negative, they need to be negative 3 and negative 7. So k minus 3, k minus 7. If anyone's doing the factor by grouping, you would do the same strategy. You'd just split up the negative 10k into a negative 3k and negative 7k, and it will get you there. So I'm not totally skirting that method. It's just a little quicker and easier to go ahead and fill in the factors when you have a leading coefficient of 1. So I am getting k minus 3 equals 0, or k minus 7 equals 0, which means k equals 3, or k equals 7. I need to check both of those. For k equals 3, all the way back in the original equation, I'm going to get a 2. I'm going to get a square root of 3 minus 3 square root of 0 plus 4 equals 3 plus 1, which is 4. And that is true. That's 2 times 0, so I'm just left with 4 equals 4. So this is a good solution. K equals 3. Let's go ahead and check the 7. I'm going to move down a little because it's a little bit big. I get 2 times the square root of 7 minus 3, which is 4, plus 4. Equals 7 plus 1, which is 8. So this is 2 times 2, there's a question mark here. I'm seeing 4 plus 4, which does in fact equal 8. So I will keep both solutions. So my solution set is k equals 3 or 7, both of them. All right, hopefully that gives you a pretty good start on all the different types of equations you're going to run into. Thank you for watching.